Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and I'm joined tonight by one of our favorite guests of the show, Dr. Parandis Tajbaksh, who've come back to talk about all kinds of wonderful things tonight. We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. As a reminder, York Universe broadcasts every Monday night at 9 p.m. local Toronto time, except for some holidays, of course. And Tuesday morning, that's Tuesday morning at about 2 a.m. UT, if that's more your speed. Now, the York Universe production works in concert with our online public viewing program. So if you're on YouTube right now, that's what you're seeing, the online public viewing run by our amazing observatory team, which of course goes for the exact same hours, 9 to 10 p.m. local Toronto time. To find out about more about our show, listen to previous episodes, and if you want to, follow the links to OPV. You can also click on any YouTube link from our website to get here for any of our broadcasts. The website is yorku.ca/science/observatory. If you have any questions or comments about our past shows or suggestions for future topics, you can always email us at observe@yorku.ca. You can also find us over on the social media. If you would like to follow along, we have at York Universe and at York Observatory on Twitter, and you're at York Universe, and Instagram, or York U Observatory, just to be a little bit different. Over on Facebook, you'll find us at Allan Carswell OBS. All of our programs are free, including this one, but if you'd like to make a donation or see some really cool observatory swag, you can always go to that same website I mentioned before, yorku.ca/science/observatory. Welcome to Monday, everyone. The current weather is a bit too cloudy to open up the telescope. Unfortunately, we looks like we will have some lovely stock images to show for tonight. Now, I'm happy to welcome back Dr. Parandis Tashbaksh to come back to our show for a wonderful, wonderful show tonight. I'm sorry we don't have any clear weather for you, Parandis, but if you folks don't remember, she's been on this show before. It's been a little while since we had her back. She has a PhD in astrophysics from the University of Toronto, Masters of Arts in Science from York University, and she actually teaches at a number of places around, including York University and the University of Toronto. She's been on here before talking about all kinds of wonderful things, but you might remember her from our pretty awesome 2022 Herschel event. Now, Parandis, how's the weather where you are?
Hi, everyone. Thanks so much for having me on the show. It's always fun to be back here. Thank you, Elena. Well, it's overcast.
Yeah. Unfortunately, it looks like we're going to have a hard time spotting even the bright stars tonight. But of course, this particular show, I think we're going to kick off by talking about some dimmer things. So we seem to have a bit of a comet theme for tonight. Now, we have a little bit of a mix for our show this evening. We've got some This Week in Space and Astronomy history, and we've got some pretty cool news around the recent Pons-Brooks comet. So we're going to kind of go back and forth a little bit. Now, I thought it would be fun to start with a real old-fashioned, just regular This Week in Space and Astronomy history. So this week, and actually today, April 29th, but back in 1989, the WWW, or World Wide Web, was first launched in the public domain by CERN scientist Tim Berners-Lee. Now, this is pretty awesome. This is the first, sort of launching of a real website across the World Wide Web. The official first website, I should say, was published in 1991 But in 1989, they had already launched the public domain. So this is the first launched public domain. And again, this is pretty early on, so this is before they had advanced websites like we have now that are linked into everything. There was no Internet of Things. There was no internet really. It was this first networked computers allowing for, of course, the what we now know of as maybe a little bit too much connectivity. Now, the world's first website came about through research at CERN, and this was a pretty interesting time, of course. There were lots of computer scientists around, young people like Steve Jobs and Bill Gates who came about it, and of course, CERN, being particle research physicists, were interested in computing, and they wanted to be able to keep track of projects on computer systems of thousands of researchers spread around the globe. And that was not how it worked before the internet. You had computers in different buildings, and if you wanted to use that computer, you would walk yourself to that other building and go inside and use that computer. But you'd have to log on to that computer when you were there. And if you wanted to use this special program, you again would have to go to the computer that had that program and go into that room physically. So the managers at CERN were interested in getting something a little bit easier to use, and they came up with an information management system. And they had something called hypertext. Now, this was actually something that existed even before the 80s, back in 1963, and this would allow you to get or retrieve a document in a computer by clicking on a word or a phrase, and that link or embedded piece of information directing you to the document was called what's called hypertext. So we use these in websites all the time now, and now they've evolved substantially. But this was part of the system that they wanted to be able to access things on potentially even other computers. So by the end of 1990, it had gotten to the point where they had been able to create the first HTML. They had a basic web browser, and the first internet was around. So 1991 was when this first ever website was really published, and the site was at info.cern.ch. And there was actually a pretty cool development in terms of copyright because Berners-Lee did not, and this is again in huge contrast to what we've seen today with IT companies and things like that. Berners-Lee actually did not try to cash in on his invention. He rejected the call to patent his web technology. He wanted it to be open and free. So that was the original website, all the way back, getting started, of course, with the very first public domain in 1989. Now the World Wide Web since then, of course, has evolved substantially, and we can now find all kinds of amazing things on it, including information about, oh, I don't know, comets, past, present, and future. If you want to know about Halley's Comet or the recent Pons Brooks or anything you can think of, you can usually get into things like the NASA website or even space.com or Hubble, and find out all kinds of great things about any topic you can think of, and probably some that I definitely can't. So it's a little bit of a shout out back in time to the very first website, because here we are broadcasting live on the internet in 2024. And now, I think we'll go ahead and loop in a little bit of commentary. Speaking of comets, we can go ahead and use this to get ourselves into a bit of comet history, shall I say, because there's quite a lot that we can talk about. in terms of the comets that are out there now and the comets that have come before. And Pons Brooks is in the news quite a lot at the moment because it's in its last few days of good visibility for Earth. But comets have always captured, I think, human imagination. And one of the ones that I thought would be a fun segue would be Halley's Comet. Parandis, are you a fan of Halley's Comet?
Of course I am. I guess it's one of those things that when you study, classical mechanics and you learn about Newton's journey and then how Halley actually used his new system of mechanics to basically predict the return of Halley's Comet is just amazing. I was just thinking, as you're talking about the computers and the web, I was just thinking, how did this man do his calculations and did it so well? And I mean, it's a pity that he did not live to see the return of Halley's Comet, what we call the Halley's Comet. But it is just amazing to me, the whole story.
Oh yes, and Halley's Comet, of course, is arguably the most famous comet in history. For our listeners who don't know, this is a periodic comet, and it returns to Earth's vicinity about every 75 years, which means that if you get old enough and you're lucky, you could actually see it twice in your lifetime. So it was last year in 1986. I did not see it then, but it is projected to return in 2061. Did you get to see it in 1986, Brandis?
No, I was too young.
Then we both missed out. So in 1986, if you were young and had somebody pointed out to you, make sure that you saw it. But it will come back in 2061, and it's already 2024. So we just have to hang in there for another about 40 years.
But I mean, it's just fascinating, Halley's Comet. Just the whole story is very fascinating to me, and how Halley, he actually used the classical mechanics, the new classical mechanics, and it was sort of, a big way of proving Newton. Uh, it has like he's the giant of physics of his time because of the power of, his system of mechanics.
Oh yes, and of course, we could maybe talk a little bit about the story there, because Newton was coming up with the most popular laws of mechanics as we still study them today. Most people do take Newtonian mechanics in their beginning physics classes, and to come up with these really incredibly useful laws. It meant, expanding things in a way that could be used throughout the solar system in this case. And Halley's Comet was a wonderful case of something that was orbiting the sun. Something that was orbiting the sun in a very interesting and predictable way. And Halley's calculations were showing that, like, well, at least for some comets, and in particular what's now called Halley's Comet, these comets do orbit the sun. And of course, Newton being around for that, and being able to use that, I'm pretty sure was very useful.
That's true. That's true. It's a fascinating story because I mean, there were so many people before him, like Descartes has some of the Newton's laws, some predecessor to Newton's laws, and then there was Galileo, and I mean, of course, there was Kepler who really calculated the shapes of the orbit, but Newton comes up with this whole system of mechanics, and then, I mean, uh, Halley taking on the task of calculating the shape of this orbit and the period of it, it's just a big deal. I feel it was a revolution for his time, and I feel still it is a big deal.
Oh, absolutely. And it's worth noting as well that the really, really excellent cometary records that existed out of China going back many, many, many years, thousands of years, were undoubtedly, if not directly helpful, at least um, part of this because we have such an interesting history of comet observation with humans. They've always been, objects of mystery, and Halley's comet in particular was described in these Chinese comet records, which go back to 240 BC, one or even farther. I believe there's some at 164 BC from Babylonian comet observations. Um, Great stuff.
Yeah, it goes back all the way to about 3,000 years ago. So that's it's a long time. So people have been observing these, and I mean with the Babylonians, they were really great observers of the sky, and they kept these astronomical diaries where they basically recorded the position of celestial objects in the sky, as well as the weather and also the political events. So what they were trying to do was to basically establish a relationship with what was happening here on Earth, and relating that to the particular arrangement of the celestial objects that they saw. So, and they recorded these in book after book in cuneiforms, and they kept it. And it's very interesting to read it. It's just a report of how the sky looks, but they have the price of the of barley and wheat, and what's going on in the state, and so on and so forth. So what you're really trying to do is to do divination, to establish what later became astrology, right? They're trying to draw a parallel between the heavens and the earth. And obviously, one of the things that they have registered is the Halley's Comet. Okay, so there is cuneiform, record of Halley's Comet appearing in the sky. But I mean, the nature of the comets was was debated for a very, very long time. And I mean, maybe we can talk about it later in the show, but obviously, I mean, the Greeks knew about it. They called them the hairy one because of the particular appearance that the comet has in the sky. Pythagoreans believed that they are sort of like planets that sometimes appear in the sky and then they go away. But I mean, it all the way came to Aristotle, who decided that, okay, these guys, they don't belong to the heavens, they belong to the sublunary area where things change and is subject to corruption. So he sort of saw them as atmospheric phenomena rather than, uh, something in the heavens. And it came all the way to the 16th century until the great astronomer Tycho Brahe proved that really these comets belong to the heavens. They are not phenomena in the atmosphere of the earth. So, I mean, yeah, they have a big history behind them.
Oh yeah, and I mean the comets have always been, interesting to humans, but even now with our sort of advanced science knowledge, as you will, comets are still really, really interesting because, they're called sort of dirty snowballs, but they're a lot more than that because we know now, Halley, Comet Halley in particular, when it came by in 1986, more recently, we had at that time spacecraft. And so they sent spacecraft up to try to figure out what this comet was made of. And Halley won't be back for quite a while. Like I said, we'll all be nice and old by then, I hope. Um, but other comets have been investigated, and the Rosetta probe, which sent back some amazing images of comet 67P. And this is a little bit harder to pronounce. Churyumov-Gerasimenko. This comet, the pictures are amazing for one thing, but they were actually able to have a probe of this comet and it was examined between 2014 and 2016, and they were able to show that at least that comet has a different kind of water than Earth's water because it's part of that mystery about where did Earth get its water from? Could it have come from comets? And seems to be no. So comets are um, still providing us mysteries and intrigue even today. Obviously, they used to be linked to omens, and there's all kinds of amazing history for quite a few comets, but especially Halley's Comet being periodic and having existed for so long. Um, it's it really is quite an interesting one.
It is. It is indeed. Yeah. And I mean, you're talking about comets, and I'm just so tempted to talk about Oumuamua.
Well, we can certainly get there because Oumuamua is, I think, speaking of mysterious things, but not a comet.
Well, basically speculate that it might be a comet or an asteroid, something like that, coming from another stellar system, a nearby stellar system. But I mean, that object is also as mysterious as, not, well, more mysterious than the comets, and the way that it has this non-gravitational acceleration. So I mean, that's a whole different story, but similar to the comets.
Yeah, and of course, the Oumuamua is a very different type of thing, just generally. So comets are pretty well understood. We think we know that where they come from. They come from the icy outer solar system, or even far out into the Oort cloud. They're icy, dirty snowballs, and they come in, they get too close to the sun, they heat up, and they can get destroyed, or of course they can not get destroyed and become periodic, or they can, get close to the sun and then keep flying away. But all those things are pretty well understood, even if we're not totally sure about, comets creating the water for Earth. Oumuamua was different, and that's what got people really excited because it was like, okay, well, it doesn't really look like a comet, but it has some asteroid density. It's got an interesting color, but it's not creating a lot of gas when it's getting heated by the sun as we thought it would if it was icy. So the question of what exactly was its composition, why was it moving so fast, made people think, okay, well maybe it was actually from interstellar space, and it obviously went out into interstellar space at a pretty high speed. So we're not going to know because we did not get any spacecraft out to see it. We have to make do with our Earth-based observations, but it came through very, very quickly, and had behavior that you wouldn't expect from a comet. Doesn't necessarily mean aliens, but it was really interesting. And I think Oumuamua is a great case of the new survey telescopes being able to do so much more now. I think that the chances of us finding more objects like this is going to be greater now that we do have some of these larger telescopes. So maybe the next one that comes by will be able to find soon enough to launch a little space probe and study.
Yeah, who knows? Who knows? That's fun. But I mean, like, even the comet, the Great Comet of 1577, that Tycho Brahe used to prove the fact that this is not an atmospheric phenomenon, was a non-periodic one. So it was more like an parabolic orbit. And he looked at it and he measured its parallax, proving that it's more than a dozen arc minutes, and then proving that, okay, the distance of this is much more than 200 times the radius of the Earth, and thereby proving that this is a celestial phenomenon. And I mean, the importance of this for our audience tonight is that before, Aristotle argued that the heavens are not changing. Okay. Then suddenly there was this comet in the sky, and it was proved by Tycho that this is basically not an atmospheric phenomenon. Well, there was the nova and there was the supernova and so on and so forth, but at least proving that this is also something. This is a star that is passing in the sky. It was, I feel, a huge blow to the whole Aristotelian system of the universe, the so-called geocentric system of the universe. So yeah, comets have been important. They are important, and I think they will remain important, and they will I guess fascinate us. We are not scared of them as the Ottoman Sultan, Sultan Murad III was scared of because he saw it as an omen for the war. The Great Comet of 77, the same one that Tycho looked at. But for us, I mean, they tell us about our origins, maybe.
Yeah, exactly. And it's good to remember is like 1577. That was a very different time. And of course, it is one thing to watch out for when you're reading about comets. If you say the Great Comet, there actually have been several comets referred to as the Great Comet. But the 1577 one uh, was also called the Great Comet, but it did come with some very, very significant um, changes in understanding. And of course, Brahe believing that this comet could now be shown to be outside the orbit of the sun and the moon. Um, and at the same time, of course, Kepler's law is coming into place at the same sort of time frame. It's really, really interesting because this would change your perspective of, life on Earth and what that means for your place in well, at that time, the universe, right? But the solar system. So yeah, the Great Comet was observed not just from Europe. And of course, Tycho Brahe's observations were very significant, but it was recorded all over the world. So it was recorded in India, I think, and Persia. And the Sultan you mentioned, where was he located?
The Ottoman as
In Ottoman, right? Yeah. So there were several records from around the world on this great comet, and when you have things that are that significant as well, lots of times they are tied to events in history and become very significant to people. And Halley's Comet that we were mentioning before is one of those ones that does come around fairly regularly. So it's actually had a couple really good moments in history, I should say, where it became very significant to one. And I thought this would be kind of a nice crossover with our This Week in Space and Astronomy history. It's not really this week. I'm cheating a little bit because I have to go back to April 21st, which is more than a week ago. But it's still kind of an interesting tie-in because Halley's Comet, being periodic, in 1910, they knew it was periodic. April 21st, 1910, Mark Twain, the author, he passes away. So he died April 21st, 1910, one day after the perihelion of Halley's Comet. And this is made a little bit more interesting because there's a fairly famous quote attributed to him. And I don't know with how much salt to take the quote, but it is attributed to him by several biographers. And he said in the year 1909, I came in with Halley's Comet in 1835. It's coming again next year, and I expect to go out with it. And of course, he then did pass away one day after perihelion with Halley's Comet. And Halley's Comet did come in 1835, actually. So it was a little bit, you get these kinds of things every once in a while when you have comets, a little bit coincidence and a little bit poetic. But of course, it's a great time to remember I suppose, not just a famous author, but also Halley's Comet and just how long it's been around and for how many people. Of course, we will get one more chance to see it in our lifetimes. But if we miss it, the next generation will have their chances as well.
Yeah. I mean, one fun thing that we might mention is the eccentricity of the orbits of these
Yes.
are huge, right, compared to the planets. And some of them come at an angle. I mean, they are not necessarily, going in the plane of ecliptic. So you're coming at an angle and the orbits are really, really elongated ellipses. So with Pons-Brooks, it's like 0.95. And I mean, the eccentricity of an orbit is between 0 and 1, 0 being a circular orbit. And most of the planets have really, really circular orbits. But the comets, like the Pons-Brooks or I mean, the Halley's Comet, they're at 0.95, 0.96. So they're really at the extreme end of eccentricity, having these elongated orbits. So that's another fun thing to look at, I think, having all these extreme sort of orbits in the solar system.
Oh, yeah, absolutely. And of course, these extreme orbits are also not necessarily stable. So we talked about Halley being a periodical comet. Halley's comet is one of the most predictable comets we have since 240 BC, but its orbital period does change a little bit. It goes between 74 and 79 years, as far as we can tell. So it's not exactly the same every time. And these comets being on these very sort of very, very, very squished long football shape, very flattened, long ellipse, means that they cross the places where other planets would be orbiting in their nice circles around the sun. They might be above or below the plane of the solar system. They might be affected by gravity from something else at some point. Little tiny pushes from things like Saturn can make a big difference when you've got a long way to go. So you can get some interesting little perturbations as comets run around, and this is one of the reasons why sometimes comets don't make it. They get too close to the sun, or they get disrupted by something, or they get gravitationally broken up. Of course, lots of us saw the famous picture of the comet getting broken up and smashing into Jupiter. But there have been a couple really good examples, and I actually found one that wasn't too far away from our current this week in space and astronomy history. So if we're talking about comets having things happen to them, gravitationally getting broken up or getting dissolved is one possible fate for a comet. And on April 23rd, just a couple years ago, back in 2020, there was a pretty good example of a great comet breakup. It's got a terrible name though. It's called C2019 Y4 Atlas. So this comet was discovered uh, by a reflecting telescope on Mauna Loa in Hawaii, a small telescope, a half-meter telescope. So this is one that our crew listening in could take heart from because we could discover this comet with our 1 meter telescope if we were able to. But the comet was discovered with a near parabolic orbit. So this is high eccentricity, period over 1,000 years. They don't have high enough of velocity to escape the solar system. So this is an extreme axis, very very squished, and the Atlas survey. So it's it's got Atlas in its name because it was part of the Atlas, or Asteroid Terrestrial Impact Last Alert System, which is a roboticized astronomical survey to find, potential dangers to Earth. So they found this thing and they said, it's a comet. We'll make sure to watch it. And it got a lot of coverage because it got dramatically bright in 2020. So this was a pretty fun comet, the Green Comet, I believe it was called by many. But it immediately started disintegrating, and these kinds of fragmentation, disintegrations of comets is very popular for sun grazing comets. So things that get too close to the sun, because they're you know they start off very far away, they're very cold, and they get just too close. They're also sometimes called Croats sun grazers, or sun grazing comets. And this one, yeah, it did not have a good time because it was discovered in December 28th, 2019. But by March the next year, had gotten very, very bright. So it got up to magnitude 7, which is not super bright. It's not as bright as, say, example, Saturn or Jupiter, but it was pretty bright enough to see in most telescopes. But it disintegrated. So after it disintegrated, it's just faded away until it was no longer visible at all. I believe the last observation for it was May 21st, and it fragmented into several pieces, and it started off in April. They found, okay, it's fragmented into 4 pieces, and then by April 20th, it had been 30 pieces, um, as many as 30 pieces. And then by April 23rd, they'd revised it to 25 pieces. So it basically split it into so many pieces they couldn't even keep track of them anymore. Um, there's some great pictures of this from some of the telescopes that were pointed at it. Of course, Hubble had a look, so if you want to see some pretty cool Hubble pictures, it just shows this comet getting blasted into little tiny pieces, and all the fragments are, of course, gassing out, and being dissolved. And some of those fragments might still be around, but they're just too dim for us to find. Which is one other thing, I suppose, for the Atlas and similar sort of surveys to watch out for, because you don't want any of those accidentally falling back towards Earth. So yeah, and of course, a huge shout out with this to Shoemaker-Levy 9, which was the comet who was pulled into pieces by Jupiter's gravity back in 1994. So there's some great pictures from that as well. But yeah, breaking up comets is very easy for these large objects in our solar system to do.
Course. And speaking of comets, maybe, and comet hunting, maybe we should also mention one of the greatest, comet hunters of the 18th century, Caroline Herschel, the sister
Oh
of.
yes, absolutely.
So she was, I think, the first, well, she was the first woman to actually take this up as a professional job and pay for it, as a professional scientist. So, apart from being an assistant to William Herschel, her brother, I mean, Caroline made a career out of, hunting for comets and making a catalog of all the comets that she observed. So that's another fascinating story that goes with the comets, of course. There is one comet that is named after her, but she actually discovered a couple, and she kept a good record of all of them. So, I mean, I think it's her story and her journey is also fascinating. She was not happy with this position at first, but just remembering where she came from, just talking about William and how during our Herschel Festival, we talked about the fact that he was a musician and then turned into an astronomer. So when he moved from Hanover to England and he finally secured a position as the organist in Bath, he decided to go back and get his sister from Hanover. And what was the motivation for that? Well, obviously, Caroline Herschel, she contracted typhus when she was young, I think when she was 10, and she stopped growing. So, if I remember correctly, she was just a little bit taller than 4 feet. And she lost vision in one of her eyes, and she was literally employed as a scholarly maid at their own household. She was doing all the housework, and because she didn't have any marriage prospects, her parents were, especially the mother, they were very, very cruel. So William, having this opportunity, decided to save his sister and bring her and help her. So he brought Caroline over to Hanover, from Hanover to England, and trained her as a soprano singer. But later, as he switched to astronomy, gradually he needed an assistant, and Caroline became that assistant to William. And I mean, well, they had their disagreements, brother and sister fights and stuff like that. But as time passed, William realized that there is really a lot of value to the work that Caroline was doing. And he actually got her a telescope and asked her to start, sweeping the sky and find any nebulae or any comets that she could see. And of course, she started discovering a couple, and she started writing, basically preparing a catalog of all her discoveries. And I mean, eventually, she became the first woman whose writings were published by the Royal Society. In the philosophical transactions, she received a gold medal from the Royal Astronomical Society, and I mean, she was given actually uh, a salary for doing scientific work. So, I mean, you never know what fate has in store for you, but Caroline, having contracted typhus and suffering so much in Hanover, ended up being one of the very few women so successful, and one of the pioneers of women scientists, of which we have so many today. And we are proud of. As a woman, I'm proud of.
Absolutely. This is probably a good time to do a couple quick reminders for our show. Just in case anyone's wondering, you are listening to York Universe. We are broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. Our website is yorku.ca/science/observatory for all of our previous episodes and everything going on this week and more. Tonight you're listening to Parandis and Elena, and we're currently discussing all kinds of comet stuff. So just as a little reminder for everybody who's tuning in this week, if you're interested in the upcoming events, I will just remind you that we do have a live in-person tour at the observatory. So we're sort of switching between atrium and observatory tours this week. This week is the observatory. So we're back at the main observatory building, which means the tour will go ahead no matter what, in person this Wednesday. Very exciting. We also have our astronomer in residence program getting started very, very quickly here. May is quite close, so keep an eye out for that with all of our astronomer in residence blogs kicking off pretty shortly. So we're just talking, of course, about Caroline Herschel and some of her wonderful comet discoveries, and arguably the first female astronomer who managed to get paid. So, congratulations to her. She did revolutionary work of her own, cataloging, observing comets, and of course, doing all kinds of uh, um, very good scientific discoveries. The comet she discovered is actually called Comet C for, I guess, Caroline, slash 1786 P1 Herschel. So if you want to look up that comet and check its position, and now you have its name and information. So her comet of course, is a pretty interesting one for, I suppose, amateur astronomers to keep up with.
Yeah, I guess you need the telescope to see that, but I mean, it's again a Halley type comet, having a period between 20 and 200 years. So this one has a much longer, period compared to Pons Brooks, which is like 70 years, 71 years. This one is more than twice. This one has a period of 155 years. So yeah, even Caroline, who lived to the ripe age of 97, I don't think she had a chance to see it twice during her lifetime. But it is pretty faint, I would say. So yeah, you need a telescope to observe it.
Yeah, and that's not to deter anyone, but it might be very, very, very small dot until it comes back again. So.
Of course.
But yes, comet finding just in general, when you first try to spot the comets, usually you try to find them as soon as possible when they're moving into the solar system, which means they're very, very faint. They haven't been heated up by the sun yet, and they're just on the edge of what's detectable. And so a lot of near Earth asteroid searches and near Earth comet searches try to focus on looking for very, very faint, dim objects to find them as soon as they possibly can.
Great. I mean, one thing we haven't really discussed are the meteor showers as are associated.
Yes, that's an excellent point. Of course, we're talking about all these comets and how they can break up and do all this stuff and outgas. Of course, they can cause meteor showers.
Right. So yeah, there is meteor showers associated with the Hans Brooks, and also with Herschel-Nicolette comet and Halley's comet. So each of these guys have an associated meteor shower.
Yeah, exactly. And a lot of there are a few meteor showers that have come from asteroids. So not every meteor shower is from a comet, but a huge number of them are. And it's very popular to name your meteor shower either after the region of the sky that it's coming from. So, of course, we have, all kinds of meteor showers up in 2024. Let's see, what are we up to? The Eta Aquarids. So there's great. I think the Eta Aquarids are the next big one.
I see.
But yeah, there's great little looks you can find for meteor showers. The Perseids are always a big hit, but you want to get into dark skies as much as possible. So 2024 upcoming meteor showers that we haven't had yet would probably be the Eta Aquarids, which is May 5th and 6th, I believe. And they don't tend to be really, really bright. They kind of tend to be low in the sky in the northern hemisphere just in the morning, so they might be a little bit hard to spot. But they're called Eta Aquarids, and they're not terribly far away from Aquarius, so that's uh, that's why they're named that. Um, but the Eta Aquarids would be the very next one, and then probably there's another small one, the Aretids, which is just below Aries, and then much more popular Delta Aquarids, um, which are quite close to the Great Square of Pegasus, which is great for sky hopping to the Andromeda Galaxy. But yeah, the Draconids in October are ones to look forward to. My favorites are probably the Orionids. I have to say, the Orionids meteor shower. It seems like it's always a good one. But yeah, a lot of these do, of course, come from comets that have passed through and left enough debris, um, that when Earth travels past it. sort of hits the atmosphere like bugs on a windshield. And so the Oranids, as I say, my favorite, they don't come by until later on in October, but those are actually from Halley's Comet. So thank you, comets, for making our night sky viewing much more interesting.
Of course, yeah, and I think it's one of those things that they should actually talk about more in schools, and in the age of phones, smartphones, and all these social media, it would be a great thing. I think it would be a fascinating journey for students to go and see a meteor shower. I believe a lot of people haven't seen them, and it would be great if one day schools would arrange for, some sort of field trip to go and see these meteor showers. I think it's a lifetime experience, really.
Oh yeah, it is one of those things you need dark skies for, and this is why I'm a huge fan of anything we can do to try to restore or obtain any kinds of dark skies for folks. I know there are some wonderful dark sky preserves around Ontario, especially in some of the parks. Um, oh, and actually, I just realized the Ada Aquarids, the ones that are coming up next, those are also Halley's Comet. Interesting. Um, anyways, fun trivia. But yeah, you do want to get into dark skies. The Killarney Provincial Park, where we run the astronomer in residence, they actually have a dark sky preserve, and some provincial parks will advertise that, and that means that they've sort of hooded off their lights, and the skies get beautifully, beautifully dark out there. The animals also like it, so it's really a win-win for everybody who's either seeing meteor showers or just wants to enjoy the night sky. So if you can go camping this summer, maybe pick an active meteor shower time and get double the fun.
Of course. So what did we miss about
Well, I think maybe as a last thing, we'll just tell folks about the comet that they can see if they're very lucky. Um, so at the moment, Pons Brooks is in the sky, and you might be able to just catch it. If you've got a really good camera, like one on a tripod, or some nice binoculars that you can set down. Pons Brooks is in the sky in the northern hemisphere right now. Not right now, now because it's set, but like today, tomorrow, and it's slowly becoming harder and harder to get an image of because it's moving low on the horizon for us. So it's actually getting better in the southern hemisphere, but not for the north. So at the moment, just as the sun is setting, this comet is sort of following the sun down, and it just reached what we think is its brightest. It's up to 4.5 magnitude. So not as bright as Jupiter, but certainly better than quite a lot of things. So seeable with binoculars or a camera where you can hold the exposure open. So if you have a way to point um, just in the direction of that sun just as the sun's going down, not actually at the sun, you can get a time exposure of this comet, and it's got some lovely, lovely tails on it. It's been called, I think, Devil Comet in the news a little bit, but that's a bit sensational. It's a nice comet. It's got a lovely ion tail, a couple degrees long. It's for 2024, which is the passage we're seeing now, it's already kind of gone past the sun, and now it's going out. So it's on its way back out to the icy outer solar system. Um, its brightening was pretty good. So it was extremely faint. I think about magnitude 23, and that is really, really, really dim when it was found. Uh, you know, um, or the Lowell Discovery Telescope, which was, watching for these sorts of things coming in. Now, Pons Brooks, closest approach to Earth will be on the 2nd of June, which we haven't reached yet. But by the time that happens, it's going to be so low in the north that we're not going to be able to see it. So you definitely want to, if you're planning on trying to get a picture, there's a couple more days where it'll be pretty good. 12p Pons Brooks, just in the west after sunset. You'll be able to catch it, and it is definitely worth getting because it won't be back again for quite some time. So this is a 70 against a 71. Did I say 71 or 74? I think 70 years, about with an error of 5 years. So again, the orbital period can change a little bit, but it's a pretty interesting one. Now, Pons Brooks, they think, might be responsible for a very weak December K Draconids meteor shower. They're not sure, so it's a hypothesis at the moment. I don't know that it's actually been confirmed. And this one, being in the sky now, being reasonably bright, there's some beautiful, beautiful pictures coming out, showing, of course, the gas and dust tails, the structure of the comet, beautiful colors coming out of it from some of the chemicals in the outgassing, and it's a great time to, I suppose, be watching it. And if you want a really cool crossover, this was the comet that was visible during the total solar eclipse. So if you were in totality on April 8th, this comet was right up there next to Jupiter. It was not that bright. It was sort of magnitude 4.5, magnitude 5, so you needed binoculars. But it was in the sky during totality in Ontario, which I just thought was really cool. Of course, despite being city-sized, it still looks fairly bright, or fairly dim compared to some of the other things. So you might have trouble seeing it, especially from downtown Toronto, because of what we talked about before, all of the light pollution. It is a Halley type comet, and we're hoping that it will come by again. But since it's going to be 70 years, I think it's going to be a hard ask for most of us to see it again. So catch it while you can. Northern sky gazers, don't wait too long, because even though Earth's closest approach is in June, it's getting extremely low down on that final horizon there. So have you managed to see it, Perandus?
No, I have not. I have not. But I just look at all the pictures, fun pictures that people take. The astronomy picture of the day today had a very beautiful picture of it too. So it was showing Jupiter and the crescent moon, and then of course the comet. So I love that website. I mean, for people like me who are not great observers, I guess it's a very good source to look at beautiful pictures, that some very creative pictures that people.
Oh, absolutely. And of course, this comet, amongst many, many others, it will also join the annals of comets that were, most likely first spotted by Chinese astronomers. So this Pons Brooks, despite being called Pons Brooks, the Chinese astronomers have records of what was almost certainly this comet from 1385, which is not as old as some of their records. But its two-part name actually comes from observations made in 1812 and 1883 by respective French astronomer Jean-Louis Pons, and then later, much later, by American astronomer William Brooks. So the naming of these things is a little bit strange sometimes. But yeah, it won't come again until 2095. So if you have binoculars and a clear view to the sunset, just wait until that sun goes down a little bit and see if you can find it in the next couple days. Fingers crossed for clear skies.
Hopefully, hopefully.
All right. Do you have any last comet hunting tips for folks, Brandis?
Really, just pray for the clear skies.
Yeah, I think clear skies would be amazing. And if anyone is wondering about um, fun comet facts, there is a wonderful resource from the Jet Propulsion Laboratory (JPL) at NASA, which is the NASA um, Great Comets website, and this is Great Comets in History that was published by JPL, and they actually have a very, very, very long list of great comets going back through time, which is quite fun. All right, everyone. Thank you very much for joining us tonight. You have all been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. This hosts this evening have been Dr. Perandis Tajbak and myself, Dr. Elena Hyde. And of course, you can always connect with us on Twitter, Instagram, or Facebook, and check out our website for show notes, content updates, and contact info at yorku.ca/science/observatory. Thanks for tuning in to York Universe, everyone. Clear skies, good luck comet viewing, and have a good night.
Bye bye, everyone.